HIIT Special Seminar, and today our speaker is Guanyu, who has recently graduated from Jiangtong University and is currently a research associate at Queen Mary, University of London. And today we are going to hear about advancing affective computing from robust perception to interpretable and fair reasoning. So please, floor is yours.
Thank you, everyone. Hello, everyone. My name is Guanyu. Today, I will talk about the affective computing from robust perception to interpretable and fair reasoning. So I will start with a short self-introduction. I have completed my PhD at Jiangtong University this year in March, and I have been 3 years in Queen Mary University since 2023 until now. From my PhD, my research focus is on three directions. One is for robust affective perception in the world, and the second one is fairness in affective computing. Third one is interpretability in affective computing. I have published 17 papers in top-tier venues, and one of my paper have been awarded the best reviewed paper in the FG conference. And I also been organizer for the ABW workshop and the competition series. I also have 3 year project experience with national level broadcasting and television company in China. And we have done 3 large-scale multimodal AI projects. And this project has been awarded 4 national AI innovation award in China. Before going into my work, I want to briefly explain why I use affective computing as the research settings. So affective computing is how machine perceive the human fact from multimodal signals. It includes tasks including impression recognition, action unit detection, valence or role estimation, emotion regulation in conversation. These tasks are different in the form of label and patterns, like impression recognition is a classification task, and the action unit detection is a facial muscle binary detection task. Valence arousal is a regression task, and the emotion regulation in conversation, it need further include the temporal and the contextual information. So the affective computing itself is much challenge, and it involves different prediction forms and different supervision signals. So I think this is a good path toward the advanced multimodal intelligence. So to realize the robust affective computing, what challenges should we meet? The first one I think is the multi-cues. Since affective computing needs to consider about like facial actions, body gestures, vocal, and language. So we need all of diverse multi-cues to realize better perception and understanding. And also, all of these cues are from multimodality, from vision, audio, and languages. So they are different pattern and different forms. And also, we need to consider about a temporal problem, because the effect is changed during time, and the long range and the short time range are diverse during the modeling process. And the last one is the modality robustness. This is a common problem in real world settings. So some modality may missing, degraded, shifted, or partially observed. So how can we solve all these challenges and realize robust effective computing? So I think my work have done for 2 directions. The first direction is multi-cue and multimodal spatial temporal modeling. So in these directions, we first study how different affective cues that contribute to robust recognition. We use facial impressions, audio signals, and body gestures. Different cues provide complementary informations. And we also find that the multimodal together, multi-cue together with the temporal changes, the robustness can be further improved. So after finish this work, we have started thinking about how does the temporal context affect the emotion regulation. So the second work we focus on the temporal informations. We propose the multi-skill temporal context learning graph that it is a graph-based modeling model. It learns dynamic perceptive field to capture the temporal dependencies at different range, like short-term range and long-term range. And it also consider about diverse modalities, including audio, visual, and text. So the model do not limit it on the fixed window, but it under the dynamic range of context informations. And the another directions of my work toward the robust effective computing is for modality completeness and domain shift. This is focused on real world settings because like we are doing the video call, the internet problem may cause some modality are missing, like the audio are missing or video are missing. So how can we solve this problem? We solving the problem under two directions. The first one is for the effective understanding and recognition, and the second one is for the generation process. So for the understanding, we propose domain adaptations. This work transfer modality knowledge, like we are missing text or audio information, but we have the visual modality. We can transfer the text information from the visual part. And in this way, we have create a unified space that align and transferable between the different modalities and to realize better and robust predictions. And the second one is we propose a generation framework. Like this work is generate reactions. One people is speaking something and you need to react realistic facial reactions. But if we cannot see their face and can only hear their voice, how can we generate a better realistic reactions? So we propose the composition progress. We create a conditional VAE. If we only have the audio or visual information, we can create a composition, pseudo features that into a unified structure. And in this way, we can generate a better and robust realistic visual generations. After this works, I start to think about some deeper problem. That is when even all these works have improved prediction accuracy, but most of the models are still largely black box system. So they can give better prediction, but often do not know whether the model behave fairly and or whether the reasoning process is actually interpretable. So next stage of my work focus on two parts. One is for the fairness, and the second one is for the interpretability. Uh, so let's start with the fairness evaluation protocol design and benchmarks. This work is based on the current uh, very important problem in fairness evaluation, because in effective computing field, there is no current established protocol. How can I evaluate a model? How it perform well on the fairness? Or is there any data set that can evaluate fairness? So this work will solve all of this problem. We propose a demographic attribute notation and partition protocols to realize the fairness evaluation dataset problem. We construct six. We reconstructed the common use six dataset with demographic notations on age, gender, and race, and we propose a standard partition protocols. So these protocols ensure the subject independence, sufficient data coverage, and consistent distribution across different split. And we also propose a fairness evaluation protocol. This evaluation protocol is mainly focused on the fairness evaluation metrics. So we systematically survey the dozen of uh, fairness evaluation metrics, including classification, regression, and detection tasks. And finally, we uh, established the four direction evaluation protocols. And these protocols can enable consistent across different tasks and different data set. So based on the two protocols, we create a benchmark and a leaderboard. We have done over 1,000 experiment and more than 50 representative models. So the following researchers can directly compare their model with current representative models and dataset. And so we have know how to evaluate fairness, but the next question is how to improve it. So we have systematically analyzes how the fairness appear at the modeling process. So at the first process, we find the fairness problem is entered at a representation entanglement. Like the facial have some information of the gender, race, and age. So it the co-founded features maybe infect the fairness performance of the model. And following is amplified by the object mismatch. So the object mismatch, because we have diverse task predictions and correlation informations, and if we don't have a better objective, the model will ignore the fairness information. So it will directly cause the unfair predictions. And also we have find the model is unstable under transfer cross domain or cross task. So how can we solve this problem? We focus on each of them, propose a method to solve them. The first one is the fair VLM. We propose a representation entanglement. We solve the representation entanglement problem by separate the sensitive attribute directions from task relevant information in VLMs. And in this way, our representation could be better disentanglement. So the representation is only focused on the specific task, do not affect by the demographic information. So realize the fairness predictions. And also we propose the fair multitask learning structure. It solves the objective mismatch problem. So this work, we unify the fairness in fairness and multitask learning process into a unified objective. So in this way, we don't have the mismatch problem, and we also consider about the head-aware aggregation that corrects the task head. So it further improve the fairness of the multitask learning process. And lastly, we learn the transfer across domain of tasks, and we propose a fair domain framework. So this work, we disentangle representations into utility-related, fairness-related, and domain invariant part. So the model can generalize well on different domains and different tasks. So the next part of my research is on interpretability. So how can we realize the better interpretability during the model understanding process? The core objective is we want to build a cognitive aligned, choral, and interpretable affective representation and reasoning. I think we can do this from three views. The first view is we can directly use the established knowledge from the cognitive theory. So we inject the information to our modeling process. And the second one is we can learn the cognitive aligned knowledge directly from data. We don't use the prior information like the first work. We can directly learn from the data set. And the third one is how to replace the text with visual to interpret affective state. This one I will explain later. So let's go to the first work. How can we inject the cognitive theory into the learning process? This work, we have established the understanding of action unit like facial muscles and like this image. The facial muscles and final impressions, they have some correlations. Like when we are smell, the corner of the mouth move upward, and this movement lifts their cheeks. And as the cheeks raise, the eyes may look narrowed. So this uh, is a very established work in cognitive theory, but it's a limited work. We use their knowledge into the modeling process. We just predict action unit independently. We predict facial impression independently. So how can we inject the information from cognitive theory into our modeling? We propose two steps. The first step is we introduce the cross-task supervisions into the label level. The label level means when I predict the impression, I know the action unit have correlations with current impression, like the smell mouse is correlated with the happy face. So when I predict happy face, I need to consider about how their smell is. And when I predict the smell, I need to consider the global facial impressions. So in this way, we let model know the label level correlations, and we also want the model to have interpretability. How can we realize this? Is we inject the descriptions, the semantic descriptions. We use a VLM model to inject the impression, valence, arousal, and the action unit into the single framework that the image and the description align. So based on the feature level and the label level, we inject the cognitive theory into the model. And the second one is if we don't have this cognitive uh, knowledge, how can we learn it from the data set? So this work, we solve this problem. We propose a choral discovery framework. This work is inspired by three cognitive theory. One is from component process model. This model means impression arrays from underlying AU generators. So we propose a disentangled AU bottleneck to learn a robust action unit representations. And the motor synergy theory propose the facial muscle, they have interactions through facilitation and inhibition. So I think we can introduce a counterfactual mechanism. If we have a smell face, a smell mouth, uh, the action unit should have a choral path to the final facial impressions. So in this way, we can create a choral structure based on this action unit and the facial impressions. And finally, we need to consider about cross-cultural affective theory. So affective is not only for population level. The different culture, different individuals, they have different difference. So this work, we propose a population level graph and a sample adaptive level graph to unify diversity between the culture and the individuals. And the last one is we learn is currently how can we interpret the effect in is we use language to describe it, but does this way the good way to implement the facial effect? For example, if on the left, if we want to describe a facial impressions precisely, we need many specific word like this is eyes raise the upper eyelid, hand cover the mouth. So it's so complicated. We human understanding not transfer your face into some languages and then understanding it directly mapping what I see and what I understanding like this process. I directly mapping to the visual informations. So This work is inspired by a famous cognitive psychologist Jung's idea of archetype. So the key idea is that humans do not remember every face when we have seen. Instead, we remember some representative or impressive facial patterns that when we see a new facial impressions, we compare it with these remembered patterns. If it looks similar to something we have seen before, so we use that familiar archetype to interpret it. If we haven't seen it, we can create a new one. So we follow the cognitive theory, create the archetype space. We can see the learned archetype have the topology structure and the fine-grained information. From left to right, we can know the upper face activation is gradually more activated. Okay, so after the robustly effective computing, fairness, and interpretability, what the future work I want to do is so toward the multimodal intelligence with more mechanistic, fair, and human grounding, not limited to only effective computing. So I think there are three ways to realize this. The first one is the mechanistic analysis of semantic formulation. Uh, so we currently don't understand what internal mechanism under the like large language model or multimodal models. So if we can location the different part, how the high level semantic arrays and how they integrate different modalities into final high level predictions and how transition criteria analysis, how can we evaluate where the arrays are high level, where is the low level info semantics. So I think the mechanistic is important. The second one is internal fairness. So current fairness is still mostly at the output level. All my work and the current fairness is only limited to the output level, but we need to see where is divergence pointed, where is arrays, where is propagate, and where is targeted intervention. We control some specific part or head or layers to control their fairness performance. And the last one is the human grounded concept and evaluations. So this one is, I think, is most important for interpretability multimodal intelligence, because currently, like larger language models, they still a black box. They don't have human aligned concept design. They don't have evidence grounded information, and also they don't have the protocol to evaluate does the concept are aligned with human grounded information. So I think the three problem is a good way toward a better understanding of how multimodal intelligence realize. Okay, that's all for my
Okay,
presentation. Thank you for your
thank you very
hearing.
much. Questions?
Yeah, I have several questions, but if someone else has a question also, perhaps we could start with by someone else.
Okay.
Or maybe we start with your first question, and in the meantime, people can think about their questions, and you can raise your hand if you want to make a.
Yeah. Okay. So nowadays these AI systems like ChatGPT, Gemini, and others, they are becoming very widely used in our societies, and this development has obviously both opportunities and threats for human societies and human learning and human intelligence. So, how do you see the role of affective computing in addressing these challenges and ensuring that our societies would get the best outcome from the progress of AI systems?
I think this one is most important at so I think the three level. So for effective computing, the first important problem is privacy. So like what I have done in the fairness protocol analysis, we create the to let the researcher and the participant to understand how their data should be used or research. And when we collect the data, we need a clear consent, let the participant know whether the usage have abounded. And the second one, I think, is accountability. I think the AI should not be replaced by human judgment. Like we do the interpretability, we do the vector computing, but all of this work should not as a final judgment. They should only limited for the support human judgment, final judgment. And also for the um, some sensitive information like we have done in fairness, I think we need to collect their age, gender, race labeling. But I don't think this is a good way. It is a shortcut. For now, we can realize fairness, but like what I have done in interpretability, we have learning how is their facial structure learned under semi-supervised or unsupervised way. So I think the next step, both on interpretability and fairness, we need to know how can we realize this by unsupervised. We don't use other supervision or sensitive information, but the model can directly infer their structure or underlying these sensitive informations.
Okay.
So that's it. Yeah.
Thank you. I think we can move to the next question. Someone else has a question.
Yeah, Valtteri, please go ahead.
Yeah, thanks. Thanks. Very interesting talk. So you showed us many quite complex frameworks and mechanisms. So I'm just interested on the process. How did you come up with those? So how often you have to have have had like a wrong route or kind of found out that your original proposal was wrong and you have to iterate and improve it and exclude those red herrings. So how has the process been in all of this very general question, of course?
Okay. Thank you. This is a very good question. So every work of my I have done is based on the wrong. Like what I have done in the first year I was participating in PhD starting, I have realized some effective computing framework, and I think it is have a good performance on the Western people, but when I transfer this to Asian people, it degraded. It can't perform well. So I research deeply under the data. Is that the problem of data set? Is that the problem of the model? So this wrong predictions make the whole agenda of my research on the fairness. And also for the interpretability is similar. So I found some similar phase. They give different predictions. The two phases are both are happy, but one is give sadness, but the other one is give happiness. This is because the happiness one is have a larger smile face, but the other one, the person seems like they have the polar face, but the eyes are small. So I think why don't I consider about the whole face correlations, the whole action unit together to the final impression recognition, not limited to some specific part. That which one is cause my core discovery research. So I think every work of I have done is from my working, and I found the problem is performance worse. So I want to solve this problem and go through to the other paths for the final research.
Thank you.
Yeah.
Okay, so I don't see any hands. So Juho, if you still had one more question, so we have time for that.
Yeah. So I would like to talk about the applications of your work. So I see a lot of application potential for affective computing in human education and in AI-based education assistants. What do you think about this application domain?
Okay, I think it can be used to two level. One level is for human interior analysis, like depression understanding, or for the education level, how I evaluate the student engagement or frustrations. So this is from inside, and for the output side, we can uh, uh, like my first work in interpretability and choral discovery, they learn from data how is the action unit construct the whole phase. They have the correlations. So I think this one can be used to some robotic uh, embodied robotic. So in this way, it can generate a robotic more have empathy. I think the empathy is very important human computer interactions. So it will generate a realistic face, and also it can understand what are you talking and what your inside feelings, and if you are confused or disgraded, disengaged, so I can change another impression tones, change another face to realize. So I think interior and the robotic way both can be as a good application directions.
Yeah, thanks. I was also thinking that this understanding of multimodal human-computer interaction could be also perhaps used to make these interfaces to AI systems more multimodal. So currently people are using these kind of text-based interfaces to ChatGPT and similar tools.
Yeah.
I guess ideally they should be multimodal like the natural human.
So like when we currently we talk with ChatGPT, we actually I have done few work on the agent work. So the agent like OpenClaw, we can create their personality for different agent. So like you are a gentle person, you are a standard person. So even if we give their personalities, they only output on the semantic level. Please be happy. I understand what are you talking. So this is a kind of word, but they seems don't understand what I'm thinking. So I want you kind. I not just you say you are so kind. I just want to you give me more help or more engagement. Let me more engagement to understanding what I'm answering the questions. But they just add some semantic word and with the answer. So I don't think it's a good way. So next part, we think we can let the model understanding what are you talking and give more targeted emotion injection, not only for give a plug in like this. Yeah.
Yeah, I agree. Thank you.
Okay, thank you. So we're a little bit over time. So let's thank the speaker for the very nice presentation, and we'll close the session. So thank you very much.
Thank you, everyone.
Thank you. Bye-bye.